Hi, I'm Tom and I talk about code. Today we're working on my compiler a little bit more, compiler written in Rust, and today we're going to do something cool and hopefully add global variables, which are going to behave a little bit differently to locals and function arguments. They're not going to live on the stack, right? They're going to be somewhere else in memory. So we're going to have to think a little bit more about memory. It might behave a little bit more like a pointer. I don't have a very strict plan for how we're going to deal with these, but we're going to find out as we go. And then if we get that done, we're going to make a minor parser change to make things a little bit less verbose. Now, I'm going to change scene this time, because I already tried to do this intro and I forgot to change scene, so it kind of sucked. I've made some changes off camera. One change has been a little rewrite of my test suite, so there's less overhead, and I have sorted things into different files for my language tests. Lang tests, there's function tests, there's compiler tests, there's conditional tests. These are good things. This is it was a very needed change. That one gigantic file was a bit hard to work with, and there's just less copy paste now as well, which is lovely. That's a really good change. The other change is in, well, I can actually show you this when I run it. So let's have a look at my test file. Now, here I have a function called foobar that returns an int. Here I have a variable I've declared as a car, and I try to assign to it from an int. Now what happens there? Because an int is wider than a car. So how do you deal with this, right? Do you allow this assignment to happen? Well, I have said no. Lang test.code. And what it says is, cannot assign from an int to a car. Okay? So how do I achieve this? Well, I wrote some wonderful code to assess the type of an expression given a context and a scope. So we can look it up. If it's a literal int, that expression is just an int. If it's a car, it's a car. If it's a variable, we have to look up if that variable is defined, and well, it is whatever type is associated with it. I now have to associate a type with a local or an arg where I didn't before. These structures are gaining more information and more context. The next step is to make error reporting useful, and that's even more context. But that's another kettle of fish. That might also be an off-camera thing, because I think it's going to be really boring. If it's a symbol defined in the context, then it's an int, because we can define these kind of special numbers that the compiler knows how to resolve. These are more like labels in assembly, things like function names. These are just ints. And if it's undefined, we throw back void, because you shouldn't be able to assign to void. I don't think I've actually asserted that anyway yet. Function calls just look at their return type if they're defined, otherwise again void, because that should be hopefully error E. Binary operations are hard, right? A plus B, what's the type? Given A and B what are expressions, what's the type of A plus B? Well, we have to work out the type of A, the type of B, and then I have this concept of a type max. And a type max just says, well, how many bytes? How many bytes? What's the deal? There is one thing I'm going to change right now. One small oversight. And that is that if other equals type void return, well, no, wait, I can do this better. Other not equal type void and this. So this has to be true and this has to be true. This is the part of the expression that catches up assigning an int to a car. We say, well, hey, we are 1 byte in size and we're trying to assign a thing that is 2 bytes in size. We can't do that. We don't know how to do that. You can do it, right? I'm going to have this kind of C-like semantic. Eventually you're going to be able to say car and do a cast. And we'll allow the cast. We'll allow a cast, but we won't allow it without a cast. That's my plan, right? Without a cast, if you're assigning to a smaller type, the compiler will say, hey, that is not possible. Okay, so this is the goal. And now, if anything has a void type, that will also be an error, which means that if we're working, like, we shouldn't get to this point where we have an undefined function. We should, like, that should fail before this point, but we'll just let the type system model that anyway, because it has to model something. Okay, so that was cool. Let me commit that real quick. lang source compiler resolve lang source compile. Don't assign void not. And I should probably run my tests just to make sure I didn't. Well, that would also that would also happen. Okay. Lang source. We'll just add this in to the last commit. Perfect. Okay. Now let's do global scope. And let's just start seeing, like, let's just start looking at what this will be and we'll work it out from there. First, let's do it from a parser point of view because that's probably an easy place to start. Now, globals are always defined at the top level. Prof Elements, catching me live. Wow, welcome. Yes, this is a very different time of stream to usual. Very exciting, very exciting. Catching me live. Okay. You're immortalized in a VOD. So you can only define a global at the top level. You can't define a global inside a function. I'm not going to do function static variables because they're really lame and not cool. They're confusing. They're just weird. I don't like them. So global var eable. It's going to have a name that is an identifier. It's going to have a type, which is going to be a type. I think, did I say, okay, yeah, constants are always ints, but globals can have a type. Globals are special. Globals are different. It has an identifier, it has a type, and it also needs to have, sorry, this is the AST. That's all it is. So we're gonna say, now we need to define the syntax, and I like doing this from the format point of view first. It's kind of like saying, what happens once we have it? How would we print it back out? That's a good starting point for writing a parser. So self global variable name var type. And what we do here is, we probably don't even need, we can just say write. Is it static? Do we say static? Should I just say global? Should I use the word global? I like the word global. I like the word global. We'll say global var type name and yeah, we'll just say that. We'll just say that. Maybe like this. So, and actually I think it needs a semicolon after it. I think it needs a semicolon. Cool. You don't assign a value when you initialize a global. I think that's easier. Static can mean a lot more than live for the duration of the program compared to global. Yeah, static. Static's a weird word. I've never liked, just from the like ergonomics of the word, I've never loved it. I've honestly never been a good fan of the word global. So that is unnecessary. And we actually want a comma here because we haven't wrapped this in braces. And yeah, I think that's it. So now when I build, we're going to get some more errors. It's going to yell at us for some stuff. P in program. How do we compile it? Let's get back there. Let's parse it first. So inline ASM, function definition. All right, let's do function global variable. And this is, again, these parser combinators, it's just going to be combinations of things we've already done. Top level. So we're going to skip the first part because this is going to be, so skip white space, and it's just going to be a token global. So we always just skip past global. Then it's the type name. Do I have type name somewhere? I do. I can copy and paste this from somewhere. Return type. Yeah, cool. Sometimes it's nice to not have to engage my brain too much. Parse type. This is a wonderful written out monad. There are other ways to write this, but you have to be very smart to do it without using tuples, without allocating a vec for the list of things you want to parse. So I'm just writing out the monad. That's fine. That's fine. S2 name is skip white space identifier. And then we need a semicolon. And that's it. We got everything we need. So we send back S3 and we give an AST top level global variable name var type. Perfect. And this still won't build because we've got to do this pesky code gen. I guess we can just do the usual placeholder, right? Top level global variable. And we don't have to worry about this panic keying around because we're going to deal with it right away. Global variable, typing's hard. Typing's hard. Okay, we're going to have a similar thing here. Oh yeah, because we run through all of our top level definitions twice so that we can handle forward, so that we don't have to forward declare functions. This is a cool little thing that I do. I think it makes the program better. That was at the wrong indentation level. Okay, nice. So now this works. Parse AST, we're going to add global variable into the list of things that it does. And I think this should go last. I don't think it really matters. You forgot I'm making a compiler and CPU ISA, not just the CPU ISA. Writing bytecode would be horrible. Yeah, the whole point of this language is to make it easier to write programs for the machine, and also just building a compiler is cool. But, you know, my assembly is a little bit esoteric, and doing everything in assembly is a lot. I did get a virtual screen working. I can't remember if I mentioned that last stream, but I do have a virtual screen that works. I have not pushed the changes from my laptop. From my laptop. I could show you if I opened this screen, or did it get pushed? But right now it's stuck in laptop land. I will bring it into the fold at some point. I also published the newest version of the UI on my website, by the way, if you do want to play with the VM. But haven't published the language yet. Publishing the language as a WASM will be a little bit trickier because there is a random generator in there. Anyway, do my tests still pass? Yes, that's good news. That's good news. Okay, let's do a test of global vars test global. We're going to try and compile global car foo. And we're going to see if this yells at me. Yep, it does, because it expected a new line. Beautiful. Okay, so we can parse a global. Now, let's add one to our test. Let's make this an int again so that it's happy. Let's say global int test equal, well, no, we can't equal anything. Okay, we can't equal anything. But then maybe we'll say test test equals to maybe we'll do this. Okay, so what happens if I try to compile this? It panics at unimplemented. Perfect. That's what we expect. So we actually probably just don't do anything on the second pass, right? We have a 2-pass compiler. The first pass goes through all of our top level definitions. If it's a function definition, it forward declares it. If it's inline assembly, it forward declares it as if it's a function, because these things are essentially equivalent in my language. The inlineness of inline assembly is a little bit debatable. It's kind of like an assembly function, I guess, rather than inline AS. I don't know. Inline may not be the word. And then if it's a global variable, we need to do something. But then on the second pass, when we actually compile the function, you know, we don't really need to do anything, because this is like forward declaring a global variable. This is like saying make this available in the context of the program to all future functions. But, well, then there's no work to do in the second pass when we actually do code generation. There's no code to generate. So that's cool. So we get a name and we get a var type. And the first thing we want to do is context. We want to define a global. Now, what is a global? Okay, what is a global? This is a good question. So a global, right? So let's say we have our program, and our program, we have our VM. Okay, our VM has a program that's running. So we have like a section of memory, which right now starts at address 0. These are the bytes of our program. We then have some other section of memory which starts at somewhere and ends at somewhere, and this is our stack. And then we have all this stuff in between, the GUI in between bits, that is just our like general RAM. Okay? And this is a very simple view of memory. Dinkelman, good afternoon, welcome. Welcome. I just tried to put chat on screen, but no one can see it because I'm on a different scene. Okay, so we've got these 3 blocks of memory essentially, and they don't overlap. And then we want to have a global variable, and it's like, all right, well, where do we put a global variable? And the answer is anywhere. We can just pick anything in memory. We could pick an address in here, as long as we don't override it with something. We can put a global. Right? But it would be kind of nice to have our own section, to have this special bit of memory that's just for globals. And we know it's just for globals. Our compiler knows it's just for globals. And then when we start asking for general purpose memory, we know that that starts up here. Don't take it from over here. No. Sad face, right? Don't take memory from globals, because these things, for example, in this test program that I'm going to swap back to showing, right? This variable test, it just has to have 2 bytes of memory somewhere that we can refer to. So what I'm getting at is, when we say when we say define global name, and this is probably actually what we do. This work probably all happens in context. Well, first off, we need to work out how we're modeling a global here. So let's say pub globals. It's going to be a hash map again from string to something. From string to something. What is a global variable? Let's put it here for now. Right? A global variable is just a memory address. So there's a fork in the road. There's a fork in the road. We could either store a global variable, let's say global A. We could say it's equal to some index and a type. Or we could say it's equal to an address and a type. There's no real difference between the two. One is just saying that, hey, okay, we're gonna keep track of this first part of the global space and then index into it. I think this is less flexible because we don't know, actually, as long as it's a byte index, that's okay. We don't know how big a type is gonna be, right? While we're saying that this is just an int, sure, that's fine. But what if we have a struct that's more than 2 bytes? What if we have things that are different sizes? What if we want a global array? Well, yeah, like what if we want a string that is located here? What if we want to make this a array of characters? Now, we're going to run into a problem where actually, if we want to say this is a list of characters, right? We probably do actually need to be able to assign to it, because just saying this doesn't really cut it. We don't know how many characters to allocate unless we have to say the number of characters, in which case this gets more. I don't know. There's actually a few things here I haven't dug into in my brain yet. Assignment. If we can assign to a global, that's actually means we'd have to generate code. Thankfully, we have a place we could do that. Thankfully, we have a code generation pass. It's just where you put that code. I guess it's like the initialization. And actually, you know what's funny? I have an initialization block. I put instructions in it here. Okay, food for thought. Either way, let's do globals without initialization for now, because it's easier. So we go back to our context. Let's say a global is, this is just going to be a plain data struct. There's not going to be anything fancy going on. Let's say a global is a usize for an address and a type. I can't use the word type, can I? var type, I guess. Cool. So this is just going to be a map from string to global. And that's it. That's all we got to do. So we say define global. And then we just need to have our little weird internal global tracker. So this is internal state. This doesn't need to be pub. No one else needs to see this. Let's say global head is going to be a usize. We'll say we add to global head t.byte size because we have that. That's part of all the type work I did. Size bytes, sorry. Common practice when we want to use a keyword, prefix it with R, LSP knows, autocomplete it for you without you. I don't have LSP running. I'm raw dogging this, but I don't know. It feels dirty using a keyword, even with a prefix. I don't know. Something feels weird about that to me. I like that Rust supports it, but I think I would continue to come up with jank names that I don't care about. Globals, insert. I think I can just use S and then T. I might have to do this. It's also common to just spell it wrong. Yeah, to swap the P and the E. I am doing structs wrong. This dude will not use an LSP, then claim he's a bad programmer. Well, that's because I am a bad programmer. I don't know. Does not using an LSP make me a worse programmer? It might. Hold on, I've got brain rot from writing my language with C-like type variable name orders. See, bad programmer. That's that's a classic bad programmer move. Okay, now we need to say into. Into from AST. Okay, so this is this really jank thing where we have to dereference it and then call into, which I don't love. I also think it's going to yell at me because it expects resolve.type. Wait, the try from a, it's not AST type into. Okay, I need to look at this. I need to think about this more. It just makes you a slower programmer. Yes, correct. Isn't that helpful if you know what you want and are doing? I like that I can think a whole idea through. Like it would catch this for me. It would be like, what the hell are you doing? It would be like, this is not it. From AST type for type. Is that not what this says I don't have? From AST type is not implemented for. Hold on. So that literally, and I think this will just be happy, and this maybe isn't the best way to deal with it, but this error is resolved by this. Extracted stir found identifier dot zero. I'm going to turn this into a ref. var type is moved. AST type doesn't. Okay, well, we'll just clone it into. Using copy here is going to be fraught with danger because this isn't always going to be copy. It's not always going to be copyable. These type definitions are simple right now. They're very flat enums, but in the future they're going to have more complicated structures. For example, imagine a pointer, right? A pointer to T, well, that type is, like, it's a type that references another type. Okay, global cannot be formatted using, debug is not implemented for global. That is easy to address. We just need to implement global, implement debug, and I don't think we can do default because type doesn't have a default. Size bytes is a private method. Yeah, when I wrote this function, my intention was for it to stay private, but actually it's useful for some other things to be able to look at the size of a type. Type cannot be dereferenced because this isn't a reference anymore. You can't dereference a T. You can't just turn a T into what would you do? It's like lowercasing a lowercase letter. It's a reference to a very good Tom 7 video. Insert expected global found type. Yeah. Okay, hold on. We need to make this a global. Address is self.global base plus offset. Actually, you know what? You know what's probably a good reason? You know what's probably a good reason to not store this as an absolute offset, as an offset rather than an address, is that we don't need to decide where the globals go. Like, we can do that last. We can do that. Can we do it last? No. We need. So we need to know the address of a global when we generate the function code, because it's going to get baked into the function. Right? It's gonna get baked in really, really hard to So okay, so we'll have a base for globals, and then we'll add our offset to that, and then we'll have var type is just whatever type gets passed in. Okay, cool. What else is good? Oh yeah, well, that field doesn't exist yet. So let's say global base is going to be another U. This one's going to be a U32, I guess. Now let's make it a U size as well, because it's a reference into a memory block thing. So this is just okay. That should be fine. S to string expected string found stir to string. Cool, done. This is exactly what Rust Analyzer would be great for. Counterpoint, this is what the Rust compiler is good for, right? It tells me when I've made mistakes. I just go through my quick fix list. This is what I keep saying, and people keep getting upset with me, but this is this is the hell I've created for myself. Okay, so this builds now, and we get the next logical error, which is that it doesn't understand that there's a variable test. Let's remind ourselves of what our code looks like, right? So we announce that there's a global. We're like, hey, by the way, there's a global. Then we assign something to it. And when we hit this line, currently the compiler's like, well, what the hell? I don't know what this is, because it doesn't know how to get a global when we look up a variable in the current scope. Now, scopes live in a block, and part of looking up a variable in a scope, we only get locals and args, right? So now we also need to go this extra step further of looking at the parent, right? Which we can do. Get some blah, blah. Wait, this doesn't walk up. Oh no, but yeah, because it's only the block. It's only the block. So now we have another case as well. So we say else, actually it's probably in this else, right? We say let parent equals self dot parent func dot borrow. We borrow this. Okay, so we borrow the block that owns this parent. And I thought this referenced to context. Shit. How do we get the context? Where does the context come in? Maybe we don't. Maybe, wait. I guess it's not a block variable, right? I guess consts aren't block variables either. Good definition. Yeah, it shows you in editor. I'm not convinced this is as useful as I need it to be. Like, the errors that I get in my quick fix list are very good. And I'm 50-50 about whether things yelling at me mid rewrite. Like, docs in editor's cool, but again, like, I can just go to the browser. I don't know. I think it's good for learning a language especially. Like, if I was doing Go on huge code bases again, like, you know, for paid work, I would absolutely go to LSP or like use a proper IDE. But just hacking around on a project that's like 3,000 lines of code or 4,000 lines. Where are we? Oh no, hold on, that's not good. Lang source. So the lang is 1,700 lines, and the VM, not including tests. So yeah, it's like it's less than 4,000 lines of code. Less than 4,000 lines of code. Yeah. Okay, so scope get. So we're gonna this gets really messy. Again though, like, why do I need to rerun the compiler as I go when I can just say make b, make in this case is alias to cargo, and like if there's an error, it just jumps me straight to it, right? And I can just step through the list of all errors and jump to them and just read what they are. This is my, and people think I'm like a psychopath, and I get that, but this is my my pet theory. Like, this is maybe not as good, right? But good enough for me for now. That's, I guess, where I am. So when we scope get, we could also pass in the context. This is one option. This is one option. This would work. I don't know if this is the nicest API, but this would work. The other thing we could do is make a function that lives in this file and say variable get that takes in the context and the scope. And then we keep the scopey part of the variable lookup and the contexty part of the scope lookup separate. For now, I'm going to try this. I'm going to try going into the block. I'm going to try adding this to our get function. I'm just going to see what it looks like, because it might be absolutely disgusting. But we'll just see. If let some global name, it's not even, yeah, I guess we don't care about the name. Oh no, sorry, yeah, we need the address and we need the var type equals context globals get s. If we get a global, then we're gonna give back some block variable global okay. Otherwise, it really is none that time. Cool. Good enough's fine. Yeah, no, and I do appreciate it. I am actually always here for new Vim tips, especially. Yeah, I do just fundamentally agree that navigating quick fix errors is annoying, and that's kind of the thing that I just want people to like consider. But I think lots of people have cool LSP workflows, and I like watching videos about people like setting up NeoVim and playing with their config. I think that stuff's very cool. Okay, so now this is going to yell at me for a bunch of reasons, and that's okay. Global not found in the scope. That's probably the most important, actually, is that okay, so I'm exporting that. So context global. What else have we got? Scope get. Yep, cool. So now we're just going to modify a bunch of things. We'll need another block variable global. The address is nothing, and then the type is the type. That's good. So yeah, so this variant just doesn't exist, which is important. I know I just said that I wasn't going to put this here, but I think I have to. Usize and a type. Okay. Argument context is missing. This is all good. CTX. There's going to be a couple of these. Everywhere we look up a variable, which thankfully isn't too many places yet. Dereferencing the borrow. Okay. Arguments to CNum variable. So this is this funny thing again. Thankfully types are very easy to copy. Context not found in this scope. Compile expression. Oh yeah, we don't pass a context through, do we? I guess we need to pass the context through when we compile. This always felt like a bit of a fluke to me. This always felt a little bit wrong, right? That we have this overall context and we didn't need to pass it through to compile expression. All right, what else have we got? CTX, just pass it, threading this context through everywhere. All right, and that looks good. What happens when we build it now? Undefined variable again. Okay, but that's progress, right? I don't know why it's an undefined variable, because we should have just said it's defined, but we'll unpick this next layer of the onion, right? So what it's saying is we don't get the global. We never, this doesn't go anywhere. This falls through to nowhere. Globals get S. So we always look for a local, then an arg, then a global. All right, I'm gonna have to go back to my favorite thing, which is, well, first let's write a test for this. This is gonna need a new file, lang test. Let's call this, I guess, global, right? .rs. Let's be very, very granular. Let's find a nice, let's just do a big copy and paste. Okay. And so this has been a fun way to work, right? Where I come up with a test case just in my weird Scratch file, and then I basically elevate them to globals. Global int. Okay, so now this yells at me. And this is a little bit more meaningful. One thing I can do. Oh, actually, one thing I can't do. This is all inside now. Common, lang tests common. After we get the result, let's just println. I didn't need to put that outside of the quotes, but that's okay. That happens. Okay, so global int. I thought this would have printed something out. Tests common 44 tests. Oh, except it happens before we get the chance to print out the whole context. Okay. We really need some more information coming out here. Maybe let's do something silly. Let's do something really silly. Okay. Compile. Instead of giving back a compile error, let's give back a context and a compile error. Okay, so wait, we've got a lot of question marks here, don't we? Where are all my question marks in this file? Yeah, there's a few. There's not that many. I would like to be able to wrap this error with the context, right? To say, hey, here's the context that travels with this error, so you can print the context out as well. So everywhere we have this, let's map to CTX, and this is gonna map. Thankfully, these already both map, so it's very easy to just add the context to this. What does this look like? Result, because of this, compile body from let block equal, yeah, okay, so this is another map, x, CTX, x. Oh, and there's another one here, map, oh no, wait, I already did that one, I already did that one. Okay, here we go. Build, oh right, yeah, well the return's obviously needed as well, CTX. CTX. Where else? What else have we got? Context does not implement copy. Does context implement clone? I don't think we can do this, can we? Maybe we can? Clone? Clone might be okay. Hilariously. Hilariously, that might be fine. CTX.clone. CTX.clone. Just gonna clone it, and this is the failure case anyway, so we don't really care if this moves a bunch of memory around. We just want to get the full context out. Yeah, okay, so clone is implemented for block. That's weird. Of all the things to block this, it was actually the block. Now block can implement clone. It couldn't before, but it can now. Wait, but unresolved instruction I think can't. Oh no, that's fine. That's fine. Yeah, so let's just clone. Function definition. Okay. Is this just like a deep dark road in general? Hash map. Clone is not implemented for global. That's okay. Okay, that works, weirdly enough. So now when we get our error, we get the entire context with it, which is fantastic. That's really fantastic. We can see global test address 0, type int. So we would expect that, oops, our code generation would find this, right? Would find this global variable. So what has gone wrong? What has gone wrong? Undefined, variable undefined test. Okay, so let's go into our code gen. Variable undefined. Assign. In assign, we say if let sum. Ah. Haha. So this isn't quite correct, is it? Right? If if we've got a what happens if we assign to an argument? It just blows up as well? That's not right. That's just not right. So let's rewrite the top level list. If let sum bv, some block variable is scope get ctx 80.0. Now we're cooking. Now we're probably gonna say match bv, right? So now we're gonna say, yeah, this And then if we have a block variable local, what's our index? Index index t There we go. Okay, that feels better. This is almost certainly gonna yell at me. Two fields. Oh, you're right. This isn't a tuple. They're just two fields. For some reason, we're not using this type, even though I feel like we should. This, because when I declare, am I not doing this type check? What? Oh yeah. Here's the type check. So I probably should do that here too. Panic R is a good line. Thank you. Do we hit it in the test? We do. we do indeed. Panic. Okay, so what do? Well, block variable global. This has an address and a type. And the type actually doesn't. The type does matter. We're going to do this properly. Where are we? Then we're gonna write a sensible panic. I'm sorry, Cricket, but I can't fully commit. Okay, so when we assign to a global, first we compile the expression. That's good. There's an unimplemented macro and a to-do macro, yeah, but they're less fun than panicking, right? I want to blow up. I actually don't know. What does to do? I have no idea. We'll find out. We'll find out together in a moment. They panic, but they're just easier to search for, I guess, right? Which is cool. In general, every panic, intention. That's cool. Every panic in this code base is something to get rid of, right? None of them are valid code paths. My program isn't complicated enough to need to panic. But yeah, it's probably better to use to do where appropriate. Okay, so the first step of any assignment is to evaluate the expression first, and we end up with the result on the stack. It's possible that we could end up with the result in a register in the future if I do a smart thing. Now, all we need to do is pop the top of the stack into register C, and then load the address of this thing. If adder is less than or equal to this, then it's easy. Then all we do is say out.push. We do this. We put the instruction. The instruction is immediate register M. Actually, no, hold on. If it's less than or equal to this, then it's easy because we do a literal 7-bit new checked adder as you, wait, literal 12-bit, sorry. Use 16. We know this is okay. So we push the instruction, oh, we get the thing in the M register. Else if adder less than or equal to 0xFFFF, then we have to do this in 2 steps. First we have to load the address 0xF. Gosh, this is a long line. Let me see if I can. This isn't going to help loads, but it helps a little. So we want to get in register M the address that we're loading. Actually, let's put it in register B. This is going to be more correct. This is going to be a little bit more correct. Okay, now we need an instruction to because we can only load this many bytes, this many bits into a register in one immediate instruction, so we have to left shift 4 and then add in the last nibble. It's a little bit unfortunate, but this is how we go. Shift left. We want to shift from register B into register B by 4 bits. This needs a semicolon. This needs a semicolon. Okay, here we go. It's happening. Then we do the same thing, but we add an immediate to B, and it's a literal 7-bit, right? Is it? Oh. 7-bit. Yeah, cool. We need to do this. I wasn't doing this properly. Now we add the last nibble. There we go. I have copy and pasted. Thank you. I have a T after a bunch of literal. Yeah. I have copy and pasted poorly. Poorly. That's cool. Okay. So we end up with register B as the address we want to load to, else if it's bigger than this, then this is another to-do. Paged addressing not implemented, right? Because if it's bigger than this, if it's bigger than an address that can fit in one register, then we need 2 registers to reference it. We need a page register and a normal register, and that is not today's problem to tackle. In theory, we can address 32 bits of memory, but in practice, I don't know if I will. I have designed my machine to support that. I don't know if my language will support that. It's a to-do for now. Maybe one day. Okay, so we're here. We've done this. The B register has the address. So now we want an instruction, which is called store word. Store word. And the order of operation is an address, a page, and then the value that we're storing. Okay, that's it. That's how we assign. That's what we do. Cool. That's it. That's done. Build it. Ship it. If this is intentional. Oh yeah, right. And then we just need to type check it as well. So we're going to copy and paste. We're going to copy and paste here. We should put this in local as well. We'll put it in global first. So before we do anything, we're just going to quickly check the types. We get the type of the expression. We get the type of the global in a format that we can actually use rather than the AST format. It's complicated, just a funny little cast. We test if we can assign, and if we can't, then that's an error. And we build this and it should still work, and we test this and it should do something. Block variable type unhandled. Block. Where did I? Ah, okay. So this is like the opposite, right? This is like, before we were assigning, this is like saying, hey, now we're an expression, and this expression needs to know how to unpack, this global so that we can deal with it. Now this one returns instructions in a vec, and I can't remember why. In general, I was trying to avoid vecs, but I don't think it matters. There's allocations going on either way. Okay. So this isn't what we're doing anymore. What we're doing now is actually the same thing we were doing before, kind of. And we probably need to copy this. This might have to... That isn't what I wanted. That is not what I wanted at all. Global. Okay, let's store word, sorry. That lives here, compiled expression, is that what we were just doing? No. Global, yes, okay. So let's mark this. Maybe this should be in a function. Oh, that's hard. That's really tricky. I don't want to copy and paste this everywhere. It's just going to be a lot of code bloat. It's going to be a lot of code bloat. Let's do it. All right, we'll just massively unindent this. That's nicer. Damn, I was off by one. This is gonna give back. Is it? Maybe we can, like, out's already mutably borrowed, right? So again, isn't quite where I want to be. Out. What is out? Out is the block. And we have. Yeah, this is tricky. I think it's okay to pass a mutable reference to the block here. I think. And then all we need is an address that we're loading, which is going to be a U size. It can't be a U16 because it could be bigger than a U16. It's going to be a U size. And then, so it's a block that we're compiling code into. It's the address and it's the target register and the page register, which we're going to pass in even though we don't use it. Cool. And there's no failure condition. Oh no. Yeah, there's no failure condition here. There's no failure. All of our checks, all of our things that return errors are unwrapped because we are asserting that they are the correct size. There is no failure condition here. This function marches forward with blatant disregard for any potential errors. Okay, so now instead of register B, this is target register, target register, copied and pasted, target register, address, page register. What did I even call this before? Page addressing not implemented. That's as good a word as any. Okay, beautiful. Is this all okay? It looks okay. It feels okay. Maybe not great, but it feels okay. And then this just needs to be prefixed with an underscore. So now instead of all this nonsense, we just say, yep, so before the store word, that was correct. That was the correct delete. Bugger, I just got rid of my mark. Load address 2. Load address 2. Now the borrow checker might not be happy with this. The block, the address. So we're going to mutably borrow out. We're going to pass in the address. We're going to pass in register B. And we're going to pass in register M as the other register. And the borrow checker is going to yell at us. Local variable with similar name exists. I235 I. We have copied and pasted. This is red alert. Oh, except here we have a vec. We pass back a vec here. Okay, this actually doesn't work. This doesn't work. We don't pass in a mutable reference to a block. We give back a vec of unresolved instruction. Okay, so let out.push. So this is actually the same. And then we just say out. Okay, so now out.push We have to mutably borrow the vec we hand back because you've got to have, I don't know. Out is already mutably borrowed. No, in this context, out was actually just mutable. It wasn't borrowed. It was just there. Also, I thought out was a block for some reason. Out is just a vec. So anyway. This is going to yell at me a bit for stuff. Target register. Thankfully, I typed that out every time instead of copy pasting, so that. Oh, that didn't help. Extra argument. That's good. Argument has type vec unresolved instruction. Let, what do we call this? Let out.extend. Oh, have I been using the scrub method this whole time? Have I been using the scrub method this whole time? That's amazing. Thank you. That's very helpful. Okay, so now this has to be a little different because we're going to call a function that gives us back a vec. So this is no longer quite as simple. Okay, so we're getting the value of this, right? So let's say so the first thing we do is this. We load the address to, and then we just we load word and then push it to the stack. And I think that's it. Okay, out. Let's SD is full of gems, hidden, yeah. Clips and interface have a lot of helpful functions. There are so many functions, it is hard to keep track of them all. And I'm learning them one by one, right? As they come up, I'm like, oh yeah, hey, that's actually pretty useful. But man, it is a rough journey. It's a rough journey to get there. Okay, so am I getting a global? Okay, that's okay. That's okay. That's not what I wanted, but that's okay. What I'm actually expecting here is this to be equal to 2, right? Because we set test to 2, we call this function with test, we return. These tests are all contrived, right? They're just to kind of show up if something breaks. Now, what I think this is doing here, yeah, so we think that the value should be 2. And Rust, well, my compiler somehow spits out the number 5,994. Okay, but there's another interesting reason behind this, and that is that, like, where does test currently live, right? If I go back to my pictures, if I go back to my pretty pictures, this global section where we give it some global offset, right? Off some base adder. Some base adder, right, that we start all globals from. The problem is I haven't done that. The problem is I have not done that. So our context, when we make it, just has nothing, just has a nothing address. Context.global, and we can't set it because the field, so this probably needs to be a new now, right? And we probably need to pass in some kind of address for this, and it just needs to be somewhere that no other memory is going to touch. Let's pick something random for now, but this isn't the correct way to do this. Actually, do you know what's a better idea? We just put it so, oh, and I went back, I forgot to change my saying. It doesn't matter, you didn't miss anything. You didn't miss anything, because I'm coming right back here to draw something else. So having to pick an arbitrary address, like, we can map random sections of memory a discontinuous memory into a 32-bit address space. So we really don't have a lot to worry about, but just for the ease of knowing in this program where to put it, right? Because if you pick something, you need to know not to override that memory with other stuff. It would be great to put it after the program, but I've got this dependency where because I'm assigning an actual address, not an offset from this base, when I create the global, the global has to know before all of this code is generated where in memory it's going to live. So I could change the order that those things happen in, right? I could make globals, deferred, like the address is resolved in a deferred way. But because baking them into the program, because referencing a global does so by address, that's actually kind of hard to do, right? I would have to extend what my unresolved instructions are capable of. There would have to be a concept of an unresolved thing that could be more than one instruction, because there's a variable number of instructions depending on what the address is, how high the address is, right? If I have to do this like weird shift and mask thing. So what if this whole is a very roundabout way to just get back to what if I just... That's not what I wanted. What if I just... Can I do this? What if I just put the globals before the program, right? What if I put this first? What if this becomes whatever our offset is, and then the program comes after? That makes sense, right? That's easy. So the offset, we pass this offset through as the global offset. But we don't know how many globals we're gonna have. So I guess we just move it forward. We just move it forward by some amount, right? So, it's a chicken and an egg problem, isn't it? Let's just move the offset forward. I don't know, I hate this as well. Both of these solutions suck. Both of these solutions really suck. This is where you need like a file format like ELF, like a binary file format that has sections, that have sizes, so you have a binary loader that makes sure there's the right memory in the right places for this. It's harder in a 16-bit address space. You really want to get this right. So where do I put them? I'm going to put it at the offset, and I'm going to say offset plus equals 20. We're only going to have a few globals. Once you've blown it, that's it. You can't have more than this. Let's say context. Can I have... Okay, we're just going to have a magic constant that does this for now. And it's going to come from context max global size. Debug assert global size 2. Unless globals can be created at runtime. This is how the source engine gets its 4096 entity limit. Yeah. Even that's probably a little bit smarter. Globals, yeah, no, you're right. I should know how many there are, but it's computationally expensive to defer knowing where to place globals until after I know how many there are. Actually, wait, whoa. Hold on. You're right. You're absolutely right. I do know how many globals I have. This is the benefit of a 2-pass compiler, right? Because... okay. This is better. Wait. This is even better. I'm going to undo a couple of things. Okay. AST. Exactly. It's all there in the AST. So let me draw again. Okay. I know everyone must be sick of me drawing these weird, hard to decipher pictures, but it really helps me get it straight in my head. So, pass 1. That's not a pen. Okay, pass 1. We collect definitions, right? We do function defs. We do global defs. Essentially, we count the number of globals, right? So here, after P1, we know size of globals, right? We know how many. Pass 2, we allocate globals. And then pass 3, we do code gen. Now, the reason I wanted to draw this out, so this adds another pass in the middle that was not there previously. The reason I want to draw this out is that actually, I think we can do all of this just in 2 passes. I don't think this is necessary. And the reason I don't think this is necessary is when we do our code gen, we have to get, we dereference our globals, right? So if I look at if I look at the code gen, if I look at my variable dereferencer, right? So we try and get a global. What if a global has not been initialized with an address here, we initialize it with an address. Now this means we would need to pass in a mutable reference to a context. So maybe this is a non-starter. Maybe I just do this in 3 passes. Maybe I just don't bother trying to be clever, right? But this idea of deferred initialization would be fun. That global pass should be trivial. This is also a good point. I think I'm over engineering. I think I need to do the simple thing. I think because it is 10 minutes from midnight and I've got some other shit to do after I finish streaming, I need to do the simple thing. All right. Hold on. It's happening. So it's here. It's compile for blah, 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 blah. Okay. So define global. Yeah, don't need a midnight scurry. Never need a midnight scurry. We need to collect globals into a different structure. So let mut global map equal hash map string type. This is it. We just map a string to a type, except this needs to be a colon. Right? So we map a string to a type. That's all the information we need. Then when we go through and actually do code gen, when we actually do this definition, we decide where they live. Okay, that's good. So global map.insert name.o var type. That's easy. Then we have to calculate the size, so we say for t in global map.keys, I think dot values, I think I can do this. Global page size equals this is very silly. There's probably a better way to write this, but we need to convert it from an AST type into the other internal representation of a type. There's 2 types. tt dot size bytes. So how many bytes does this take up? We advance by this. Then for kt in global map.iter, we define the globals. Define a global, and this time it's the k, it's the... Actually, we should var type dot into. We can do that cast here because I think I actually said, right, it's just a type, not an AST type. That's good. So t, and then it's the t. Whoa, page size. Yeah. Okay, that's probably better actually. Hey. That's nice. I'm gonna use that. Thank you. I'm a bit scared of fold. I don't really I haven't quite worked out Rust fold yet. I like fold in general. I like a good fold in Haskell. Fold is lovely. I'm just a bit scared of it in Rust. Okay, so that's good. Now the global. So now we just offset this by the global page size. I don't know. I just tend. I had some issue with it one time. So it just wasn't clear what the error was, and so that was hard for me. I can't remember. Honestly, I can't remember, and I'm probably just better at Rust now and could work out whatever my problem was. And don't say my problem was not using LSP. Don't even think about it. Oh no, sorry. Don't get me wrong. It's not actually an issue. I'm not saying there's an issue with fold. I'm saying there's an issue with my brain, and that stopped me using fold. Okay, so context. We need to make a new pub fn new, which is going to take a global offset as a U size and give us back a self. Iterators come up with funky errors, combining nightly one. Yeah. Also, when you have, I think my issue was I had a borrow, like I was trying to fold over a borrow, like a ref to an int, and it was just blowing up. I was doing bevy stuff. I can't remember the exact context, but it was some weird nested game stuff that just didn't want to work properly. And I gave up on using fold, and I did a for loop, and it worked. So I just stuck with my for loops. Okay, so we give back self, global offset, and then the rest is default. That should be happy. Global map, hash map not found in this scope. Oh my gosh. Offset, expected U size found as U size. I think this probably should actually be a U32, but that's okay. Not type dot into, type not implemented for. Okay, so this is, yeah. Very does a ton of things. Trying to solve admin of code question last December. For loop runs perfectly fine on real data, fails on test data. Yeah, look. So you take a correct answer in advent of code, right? You take it, and then you move on to the next day, and you never think about it again. That's good. This we can just deref, I think. U32 found U size, so we're going to cast this back into an as U32. This is a real abuse of numbers. Don't do this. Don't do this. But that's okay. Now this isn't mutable anymore. Beautiful. Yes, that's what I love. That's what I love about a good fold, right? When things don't have to be mutable. String does not implement copy. That's okay. We can just turn this into a string. String that really went on a wayward journey. Var type moved. Okay, so actually I just have to say, this is what I had before, right? Clone into. Global offset unknown field. Global offset unknown field. Context. Global base. Global offensive. Default not found in the scope. That's because I need self default. Okay, beautiful. What does this look like now? It still fails. It fails with the same thing, but that's okay. That's okay. Interesting. Now, I think I print out the context at least when I blow up, right? So, yeah, before all this. So these are all the instructions we run, and this is probably useful to look at. We set up the stack pointer. We shift left. Blah 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 blah. SP0, blah, 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 blah. And where do we... Well, the first thing we do is we set it to 2, right? So 2 push B0, store word B0. So this is saying that this is still ending up at address 0, which is not correct. Which is just really not correct. So let's go back to lang tests common, right? And let's println, except let's do it a little bit neater. So at least now we're going to see everything that's going on, right? We get all of our stuff, and we need to go back to our context formatter, and we need to write globals as well. Okay, so we get self.globals.iter .map. What have we got? Globals, string global. So we get K, G for global, obviously. Format K equals, and let's just do the lazy thing for now. Format it, and then collect it into a vec, which feels horribly inefficient because then we just join it together into a thing. Thank you for your encouragement. I appreciate it a lot. That's a really cool name. Okay, so we have test, which is the global, which is at address 0. Which is at address 0. Cool. Why is this at address 0? Wait, no, it should be at address 0. That actually makes sense. That makes sense because our offset is 0. We're starting at 0, right? We're starting at 0. This is okay. We just shove all of our stuff at 0 initially. Huh. But now the program doesn't actually know that it's being put at a different offset, right? The program doesn't know that. So the program doesn't know it has to go somewhere else. So in the context, we need to know this. We need to know pub program start offset. These are two very important things that the context is responsible for communicating back to the host program. So context, we say context dot program start offset. We actually do this way up here. We actually do this way up here at the start of this pass. It's program offset. Cool. Okay, program start offset. So we now have a reference to this. So now in our test handler, we can res map program bytes. We copy this to res dot program start offset. Oh my gosh. Okay. This actually should be a U32. This should be a U32. And okay, well, it did something bad. You're a Haskell programmer. Okay. It can do both. These aren't mutually exclusive. Oh, the lazy thing. I get it now. I love a lot of things about Haskell. I would love to do some Haskell dev at some point. It's just hard. It's just hard and scary. But inline ASM now blows up. What the hell? Why does this blow up? What's going? Okay. You work on a compiler in Haskell, like for your job or just for fun. It is just gone past midnight. Super Cricket has wished the Americans happy 4th of July. I'm guessing they've just ticked over because they're like 12 hours behind. Wow, that's really cool. Job. That's the dream. Why? How do you get a Haskell job? What do you have to do? How do you do that? How do I get a Haskell job? That's what I want to know. That sounds really cool. Enslave yourself as a PhD student. That sounds uncool. That doesn't sound good. I don't love that. It's fun. I could imagine myself getting really into a research project. I know people who are doing PhDs. Like my dad started a PhD that he never finished. I know what it's like, you know? I'm looking for someone to raid, by the way, while I wrap up the stream. I am looking for someone. If anyone has recommendations for a cool streamer that's on now that I can throw some love onto, you know, I can always do that. Otherwise, I'm going to scroll through software and game development and find someone cool. Mr. Weeble, animating stream. Let's do it. Let's do it. Mr. Weeble. Arch, you shouldn't install hash tool packets directly. Yeah, I have the same thing actually. Pac-Man really, yeah, really makes them, man, really makes them granular. Okay, Mr. Weeble, let's do it. Let's throw some people over this way. Stop using bad distros. One of my friends is doing a server install on NixOS at the moment, and he's almost convinced me to do it. I'm 50-50, Mr. Weeble. 50-50. I'm thinking of FreeBSD or potentially NixOS. But for my PC, I think Nix would be cool. Government. Yeah, I don't know what's going on with the governance. I heard there's some issues. Is GUIX having the same issues? Is GUIX more stable? Because Lisp is also cool. Lisp is cool. All right, we're gonna throw this onto this very strange looking channel, and I hope it's a good idea. Cricket, this is all on your head. Guile is definitely better than Nix. Ooh, that's controversial. I love it. I love the confidence with which you say that. Anyway, happy to hang out and chat, but I need to take my meds and get to bed. Thank you all for tuning in. This has been good fun. Let's see what's going on over in Mr. Weeble land. We won't blame me. Good time on a break. Oh, well, whatever. We'll throw viewers over and we'll see what happens. See you guys next time. It was awesome to hang out in a different time and have some different people. Thank you very much for the LSP tips and the LSP chat, and let's do a raid. Bye.